If that's okay with everyone.
You're not recording anybody.
No, it's just me. Just me. Just a little face cam in the corner. Alrighty. So let's get started. Today I'm going to present a system I've developed over about 2 years, 1 year, 1.5 years. It's a way to move between different Jitter instances all within the same patch. So I guess a little bit of background of how this came to be and how I saw the problems with how I was working with Jitter before and how I addressed them with this transition system. So I served as director of the CSULB New Music Ensemble during our year on Zoom. We performed very improv-heavy works that embraced the latency, so we weren't really concerned. That wasn't a problem for us. So as a result, I challenged the ensemble to write pieces and have them performed live over Zoom. And we were the only ensemble to do so during the pandemic, probably because of the type of music we played, but I was still very excited for that. So the first couple of concerts was just the Zoom window. This is actually a crop of the YouTube live stream. You can actually see like the edges of the Zoom window where it says original sound and all of that. So, and everyone's names are on there. So it wasn't the best, to say the least. But this was right at the start of the pandemic, and I was very happy just to have the students be able to perform live again. The Zoom window got boring. We did 3 concerts that fall semester, fall of 2020, and the first concert of spring 2021 comes around, and a student asked me if he knew I worked in Jitter. He asked me if I can do some visuals for his piece. I obliged, and we came up with, we collaborated on this together. This was the first concert of spring 2021. But that was just that piece of the concert. There was a few other pieces in the concert, and again, it was just the Zoom window. Just how the format of the concert worked. The one with the visuals was first, and the other ones were after that. So it was pretty anticlimactic. So we get to the last Zoom concert of the Zoom year. I wanted to add unique Jitter environments for each of the 8 pieces. So here is a few samples of that. First, I wanted to move away from the static nature of the Zoom boxes, so I really tried to not show them as much as possible. But the problem is, I was doing everything for these concerts. So I was mixing through this podcasting service called Clean Feed. I was managing the live stream, so pressing go live on OBS and moving through the different scenes if necessary. And I was overwhelmed, so I wanted a way to make it as easy as possible for me to move from one Jitter instance to the next. So that's how this came to be. So I developed a system that allowed me, all within a single Jitter patch, all with the same Jitter window, or the jit.window object. Everything was going through there, so I didn't have to do anything in the Jitter patch other than press next scene. So I'll go over the very first version that I developed, but functionally it's the same as every other system, or all the other iterations in the future. So just a little rundown of how the data flow works. Each scene, what I call scenes, are self-contained Jitter instances. It draws to a JIT layer, which is then put onto a unique jit.world with @visible0 and output texture 1. So I can have as many of these scenes as I want, and you won't see the windows. That is then goes into a fader module. It's just a JIT GLPix with some vector processing, fades based on scene index, and it draws onto the another JIT GL layer, which is then put into the output world. So all worlds are from each scene are drawn onto the output window, and this is the one audiences at home actually see. So let's go over a little bit of how that architecture works actually inside of Max. So I encapsulated each of the scenes into their individual scene, into an individual subpatcher called scene control. Inside of scene control, there's 2 layers of scene control. This top layer is the scene indexing, scene index matching, and fading. Inside of this P scene object, you have the actual jitter stuff. So the stuff you see is inside of this P scene here, and that is what's variable in between each of the scenes. So every scene control patch looks like this, but every scene inside of the scene control is going to look different, and we'll see that when we get inside of the actual patch in a little bit. These JIT-GL picks are the fader modules. You have a local fader module and then a global fader module, just so you can fade in and out if you want to. And then this is what the fader modules look like on the inside. And lastly, you have the JIT-GL layer, which is drawn onto the output world, as I call it. And that's the end of that. So let me actually pull up the patch. So here's the version no, that's the wrong one. Where's this? Yes, here it is. So we got a nice big display here. So I got tons of room. You know what? This is actually the wrong one. Good old-fashioned recent project. Here, yeah, this is the one. So this one right here, this is the template, and I'll show you that in a little bit, but let me just show you sort of what a completed version of this looks like. So you can ignore everything in the bottom half of the patcher. I had some DMX controls and stuff like that, but that was just extra stuff I added on. So I can move through the scenes, maybe, if it decides to work. There it is. Okay, so there's a glitch where it doesn't activate all the scenes, so you have a bunch of empty layers drawn on top of each other before the JIT worlds are activated. I think it'll be better if I just restart Max. Open recent project. Okay, that's why I didn't. Round 2. All right, there we go. Cool, and hopefully it works now. Yeah, there it is. Okay, so as I move through the scenes, each individual scene you see is its own jitter. What was its own jitter patch I put inside of here. So and also you can have webcam control. Yeah, so it's just a very nice system if you don't want different parts of the jitter interacting with each other, because if you don't want this stuff being shown at this point in time, this makes it a very easy way to do that.
That one's beautiful.
Thank you.
I like that one.
This one's fairly similar to that. I was running out of ideas at this point. And then this one right here is actually a video playback. It starts faded out, but trust me, there's video. See, there it is. I believed. So yeah, that's sort of what a built-out system looks like. I won't show you the inside of the patcher because it's a little messy. Yeah. Woo! I mean, okay, so I guess I'll show you. So we have the scene control. I have a little shortcut here to get inside the scene if you actually want to edit the jitter instance, but I'm just going to go inside the scene control I updated it a little bit from this version, but it's the same basic thing. It's just having scene. This is just the scene index matching. And then if I double click inside of here, here's the actual jitter patch. And so...
So which one is this?
This is scene 1. So if I index back to scene 1, it's this one. So
this is the patch that creates this
correct.
chaotic static.
Correct. Yeah. So and it's all encapsulated inside of this single subpatcher. So sort of the controls of the patch and the actual video being generated don't overlap at all, which is something nice about this. I guess if we don't have any questions in particular about what I'm doing here, I will open up the template, which is somewhere. Here it is. So here is the template. So I have a template saved. This is the patch that's from the template. So if I go into new from template, there we go, version 4.9. But I'll show you if you want to make this a template. I'll show you how you can do that by dropping it into your templates folder if you're curious. But essentially how this works is I have some pre-built jitter stuff inside of the default scene controls so that you can tell that it works. So if I index the scenes, it just, and of course it didn't load, there we go. So it's, it just loaded a JIT noise that's being drawn just to show that it's working. And if, I guess for me personally, or if you decide to use this, what?
So do you have one scene control for each performance basically, or for each unique patch that you want?
Yes, each unique patch.
And then at this point, you just have a sort of a generic patch that's icy.
Yeah.
So this red one is kind of just the starting state, and then you would put stuff in there.
Yes, exactly. So if you open up scene control, none of this stuff you really have to touch at all. And maybe if you want to mess with the scale, the exponent on the scale, if you want to make it fade in, change the characteristics, how it fades in and fades out. But you don't have to touch anything in here because I made it so it's easily iterable. So you can copy and paste any scene control you want and just change the argument. And now this is its own scene control. And the way I set it up, it sets a maximum, the number of scenes plus 1. So I'm going to change that to 5 real quick. But now if I move up to 4, we get a brand new scene that's theoretically different from the previous scene. Yes. I hope it generated black and it's... But, so everything inside of the scene control subpatcher handles the argument, so the scene number. It works with decimals too. So if I wanted to call this scene 4.5, and then in the current scene, change it to, I don't know, 2, just to prove it works, and then go to 4, nothing, because it doesn't match any scene indexes, and then go to 4.5, theoretically, and if, did I not press enter properly? I believe. Maybe it's not working properly, but theoretically it should work. But who uses decimals anyway? Anyway, so just going over the different parts, I guess I should have preferenced Jitter is a way to generate video inside of Max. There's 2 types of jitter data if you're not familiar. You have jitter matrices and textures. So matrices operate on your CPU and they're marked by these. Let me see if I can find one. Oh yeah. So these little green cables are your matrix data. And then you also have texture data, which is based on OpenGL. operates on your GPU, so it's much more efficient. And they're marked by these little blue cables. Generally, most texture objects are pretty good at, if you plug a matrix into it, it converts it to a texture automatically, as long as there's a corresponding jit.world to render that texture data. But matrices it's not very good in the opposite direction. So the way I've set up these patches are, if I need to use matrices, they're in, I start out with matrices if I need to use them, then I convert it to textures either through JitGL layer or some other, if I'm using texture specific objects, I convert it sooner. If you're familiar with working with jit.world and textures, you know there has to be a jit world or a JitGL node if you're old school with, what was I going to say? A corresponding jit.world to what the textures are being drawn to. By default, in the scene template, I set it up so it generates a random 4-digit number and puts it in front of or behind the scene template name. And then I use these PV objects to move that data around. PV is very similar to send, receive, but it's based on patch hierarchy. So no patch at the same level as this patcher can see this variable, if that makes sense. So all the subpatchers in this patch can see it, which is great. But if I were to open up another iteration of this template, there won't be any namespace conflicts. So that's being used with this PV stuff inside of the scene control. Or sorry, I'll use the shortcut. Click this button, opens up the scene automatically. Just saves a little bit of time or a lot of time depending on how much you're using. I use these PVBR objects, which are the render bangs for each jit.world. And I have this PBR, which just encapsulates all of everything you need when working with a PV object, because it's just a little bit different than a send and receive. You need to send a bang to a PV to update it. So I just made these little subpatchers to just encapsulate everything you need. And then also PVs don't send bangs, they send zeros. So that's why I have the cell 0. So if you're, I don't know, instead of using, if I wanted to do this instead, where it generated a random color every frame, that's how I would set it up. Or if you need any render bang specific features, that's what this is for. We have this pstop object, which sends out a 1 when that particular scene is on, sends out a 0 when it's off. So that's good if you want to make sure you're playing back a video and you want it to start at the beginning of the video when the scene starts. And I've done that before using this system. And it's the same thing. It's using a PV so that there's no crosstalk between any of the scenes. And it's using a change object because it's outputting a 0 every 10 milliseconds because of that metro. And I only care when it changes from 0 to 1 or 1 to 0. So that's what that's for. So I don't want to get too deep in the weeds, showing an example of how this is built. But if you would want to add your own stuff, you would just delete all of the stuff in here. Maybe keep the PV stop and the PR1 for your own use cases, and then just delete all this and then build your own. So I don't know, let's drag in a movie. Ball. And I gotta make sure to put volume 0. That's true. It's when I first started to use Jitter, it was very confusing that Jitter movies did not listen to the how sound works inside of Max, because you're just used to sound moves through patch cables. But now when you use Jitter videos, they don't. They just exist. So that was very confusing for me. I'll make sure to click the volume 0 so I don't hurt you all. And then I'll turn on loop, and then I'll just put the matrix output into the JitGL layer. And this was scene 1. So I'll take this back to scene 1. And there we go. So our favorite boy, who I've seen this video so many times. So yeah, I think that's a good overview of how this works. Generally, at least the times I've used this, for the most part, I've just built inside of the scene controls, but there's nothing stopping you from copying, pasting a existing jitter patch you have, and just making sure you plug it into the JitGL texture or JitGL layer down here, and making sure there's no conflicts with a jit.world if you already have that. But yeah, I think that covers everything. So this is your scene index stuff. You can change your scene transition time here. This is your scene template name. It automatically generates one on when you first load the patch, but if you want to make your own scene name, just make sure to delete this offset prepend patch cable, and then you can call it anything you want. I'll just say Max Meetup LA. And then now, and it automatically iterates the patcher name through all of the PVs. Yeah, and I have this load bank to this patcher if you just wanted to reboot the patch real quick, if there's any problems with it, because I run into problems frequently. Yeah, I think that's everything. I guess I'll take any questions if anyone wanted to see anything specific or had any questions about this. Yes.
I may have missed this somewhere. How are you automating what depth it's at? Just you had a layer, and there's another layer, and then there's an outer layer.
Right. So I'm not controlling the depth at all. I'm just using the
Alpha.
Yeah, I'm just using the JitGL picks, and it's fading out all of the ARGB components. So it doesn't matter if they're on the same layer, because the way this is set up, you don't want two scenes on at the same time. And if you wanted that, that's an artistic thing, and it should be inside of one scene. I don't imagine this is like a very artistic sort of, or using this for creative means. I designed this just purely for organizational means. But by all means, if you want to turn this into a sequencer, you know, that's great, or make any edits to this to make it more creative. But in my use cases, I always use this for a organizational template for both live streamed performances just on my computer, and also for live performance with projected background. I used it to so you don't have an instance of that I've done plenty of times, and I've seen in a ton of electronic performances where you get to see the performer's desktop as they're switching patches. So this is great to avoid that, because everything's all set up all in this patch, and you just have your output window full screened on the projector, and then no one gets to see your desktop picture, or how many files you have on your desktop. Yes?
So is a way to think about what's happening here that you have the JIT.world is like this virtual 3D environment, right? And then the JitGL layers are almost like sheets of paper that are floating in this 3D world, like right up in front of the camera.
Yes, exactly.
And then you have basically as many of those sheets of paper as there are scene control
Correct.
patches. And then to control which one is visible, you're basically just selectively making only one of them, like you're making all the ones that are not the one you've selected transparent, basically.
Correct. That's exactly how you can think about it.
So it's a video.
Yeah, it's a video switcher inside of Jitter, where the individual Jitter scenes don't talk to each other at all. So there's no sort of overlap. Yes?
Are they cross-fading, or is it one fading out and then the next one fading?
It's cross-fading. So the way I've designed it is in the scene control subpatcher, when it receives the correct scene index, it turns on automatically. But when it changes scene index, it waits for the fade or the line object to hit 0, then it outputs the 0. Because in earlier iterations of this patch, I didn't have that. I had it turn off the jit.world immediately. And that's another important consideration, is that the jit.worlds in the background turn off to save on CPU when they're not visible, but it waits to turn off until it's completely invisible. So that I've had issues where, our ball man would freeze and then fade out. So if I just to demonstrate that, if I switch scenes, it moves completely to the next scene before fading out.
And so now behind the scenes, ball person has stopped moving
Yes.
after the fade has been completed to make it so that the computer doesn't
Yes.
have to worry about.
So it's paused here.
And that's because of the P stop?
Yes, because of the P stop, it sent out a 0 when the object or when the scene changed, and so.
So the fade completes and then the P stop says 0.
Yes, correct.
If you went back to that scene, it would say 1.
Yeah, it would turn on immediately. So let me just throw up a message in here. So if I go back to scene 1, decrease, it hit 1 immediately, and then if I change it, then it hit 0. Anyone else? Yes.
I'm interested in what this master fade does, essentially.
Yeah, so it's fairly simple. If I pull up the window, if I fade it out, it just fades out. There's just a second instance of that JitGL pix that's controlling the scene indexes, but all of the scenes have the same master fade module, so they all fade out with it. Yeah, that's how I'm operating that. Instead of because the other way to do that would be to have have this JitGL world output to another JitGL world and then fade between them, or maybe you can do not at visible 0. There's probably some argument or attribute, because there's a million attributes on jitter objects to do what I did, but I found this to be the simplest way.
Does master fade activate the P stop as well?
No, it doesn't, but that's a good consideration. Maybe
When it hits 0.
Yeah, when it hits 0.
Still 0.
Yeah. That there could be a PV master stop, and that could be the way you accomplish that. But I haven't had an instance where, honestly, I haven't used the master fader too much. It's just a theoretical thing. I'm like, this might be useful, but in performance, I've never actually used it. This is probably more for if you're trying to time it with an audio performance and you want to fade out with them, and they don't have a fixed time on their audio performance for whatever, or their music performance. So you just wait for the end and then fade out with them. But it still operates in the background. Yes.
Are you going to make a version for audio?
I mean, that's a good consideration. I guess the reason why I built this in the first place is because people can see my computer screen when I do visual performances, but generally no one sees my computer screen when I'm doing music performances, right? So switching between different patches, at least for me, is not a big deal when I'm doing an audio-only performance. I guess with jitter, there's way more crosstalk between all of the different objects, because jitter, or at least JitGL stuff, communicates wirelessly oftentimes. So for me, I got confused a lot, and why I built it. Part of the reason why I built this is because I was confused, like, oh, why am I seeing this? I shouldn't be seeing this because it should be turned off. Why isn't this drawing on this jit.world? Stuff like that. So I haven't really thought about doing it for an audio version of this. But definitely all of this could do the scene index instead to like mutes, or I don't know would individual DACs in each subpatcher, would those turn off and on with audio? Or you can turn on DACs for individual patchers. I don't know about subpatchers inside of a other patch, if that makes sense.
I think you can.
Okay, that would be the replacement for the jit.worlds then. Yeah, so
Did you have everybody's window in a different scene, or were they all just one scene?
yeah, so the way I did it, I screen captured the Zoom window using Jit.desktop. And then I was just processing sending that matrix to all of the scenes. So I didn't have an individual Jit.desktop for each scene. And then that was being sent to a Jit.window, which then I screen captured that using OBS, and then I live streamed that. This was a year and a half ago. Now I'm a little more familiar with NDI or Siphon. That's probably how I would do that now if I was still doing performances like that, sending video, instead of screen capturing, sending video directly into OBS.
Did you just have a piece of ice in there? Did you block ice in your computer?
Well,
Because I'm like, how did you get it to
right. Well, it was running at 10 frames a second or less. Probably seconds per frame would be a more accurate way to describe that. It was very, very choppy, but I was running it on a M1 MacBook Pro. So at least it wasn't super loud and super hot. But and I think I was doing it before Max was native on Apple Silicon. So additional performance bottlenecks. But it worked. Even if it was at 10 frames a second, I was happy to, just give an opportunity to the students to perform live.
They probably all thought it was Zoom anyway, right? It's like, oh.
Well, yeah, to them, yeah, I can talk about this forever to, living in the Zoom era and having to deal with people, non-tech literate people. When we went into person, I was surprised how much more rehearsal time we had, because we probably spent 30 minutes of each rehearsal setting up Zoom, setting up clean feed, sound checking everyone. So I don't miss it. But we managed to do some interesting things in terms of everyone's computer is handling their blanking out the background, right? So my computer didn't have to do all of that processing. So it was interesting in that regard. But yeah, anyway, I can talk about that separately if you like at a later time.
Yeah, maybe one more question.
Yeah.
I've used Siphon. I don't know what NDI is.
NDI, I forget the acronym. New Tech Digital Interface, something like that. It's just video over network. So you can send video from one app to another inside of your own computer, or you can send it over the network from one device to another. So
Is it cross-platform?
yeah, it's cross-platform, Mac, Windows, Linux. There's some.
And mobile.
Yeah, I have NDI apps on my phone to theoretically wirelessly move video from my phone to my laptop. Wireless doesn't work too well, but when you're plugged in over Ethernet, it works great.
We'll definitely do at some point a discussion about how to pipe video around, because I know it's something a lot of folks have asked about, and it also factors into the question of recording, which is a really common question with Jitter. So we'll definitely, I think we already have it on our list of ideas of how can I pass video around between things like processing and Macs and OBS.
So thank you, everyone. If I have more stuff on my website, if you want to check that out, CameronJohnston.xyz. And also, this patch is on the GitHub if you want to download it, play with it, and save it as a template. And that's how I work with the patch. I open up a new template so I can create a whole new version every time, and I'm not copy and pasting between old patches and new ones. But anyway, thank you all so much.